14 preview exercises. In the last lesson, we discussed how to transform a parent function by shifting it up, down, left, and right. We're going to practice this skill on a new parent. So a parent that we haven't seen before. It's called f of x equals sine of x. It's a wave function that you'll learn more about in a pre-calculus course. Here's a picture of it. It's the graph of sine of x. We want to sketch the graph of g of x, which is the sine of x plus 2. So the thing that I have changed is not inside the parentheses. The x is not changed. So what I'm doing is I'm changing the y. That plus 2 indicates up 2. Okay, so I'm just going to pick some key points on this graph and move them all up 2 and then connect. So anything that's on the x-axis is going to go up 2. So I'm looking at all these x-intercepts here and moving them up 2. There we go. And then I'm going to take all my maximums and move them up 2. So all my high points go up 2 units. Another one. There's a high point, move it up 2. Then I'm going to take all my low points and move them up 2 units. So this one moves to here. This low point moves to here. This low point moves to here. And this low point moves to here. And then I connect all these with a nice smooth curve to make it look like the graph of f, but just shifted up 2. So that is g, sine of x plus 2. So it's kind of the nice thing about transformations that you don't have to know anything about the parent. If somebody tells you what it looks like, you can graph any of its transformations, even if you have no idea what sine of x means. Okay, I'm going to do another one. This time I'm going to shift sine of x. I'm transforming it, but I'm changing the x value, right? So that says x plus 1.57. I'm changing the x value, and whenever you change the x value, it does sort of the opposite of what you expect. So you would think that that would move right because of the plus, but when you're changing the x value, it's actually the opposite. So that's going to move left 1.57. So I'm going to look at some key points and move them all left 1.57. So I made this grid so that each vertical line here, the tick marks along the x-axis, are 1.57. So this point moves here. So I'm going to do all my x-intercepts first. All the places where I cross the x-axis. I'm going to move them all left by 1.57. 3.14 goes left to 1.57. 6.28 moves left, left, left. There we go. Now I'm going to do all my high points. Move them left. So this high point moves over here. This high point moves over here. And then do all my low points. Move them left by 1.57. Okay, and then I'm going to connect all my green dots with a nice smooth curve so that it looks like my original function sine of x, but shifted left by 1.57. There we go.